We get experimental science. We're curious, non-judgmental.
All right, there she is. Hi, Neuro.
Hello.
And we have audio. My God, everything is working.
Yeah. So you'll notice my background is different than usual. My home internet decided to not participate until like half an hour kind of thing. It just noticed. So I raced to the lab. So you're actually getting me in the lab.
I am so sorry. Thank you so very much for coming on. And then let's give Neurolicia a shout out. Y'all, please go follow this absolute legend. She won't say it, but she's got a star on the Hollywood Walk of Fame, which is pretty cool, I think. Womp Womp, Saphira's Mama, and Dougalicious, welcome in. Welcome in, What a DB. Yes, Neurolicia's amazing, but let's not comment on looks. Awesome. Well, thank you so much for taking the time and having to go back to work to do this. Like, oh my God.
I kind of like being in the lab late at night because then I get it to myself most of the time. I can listen to my music. I just would prefer that I had my cool ambient background with all my mouse plushies and stuff so I could sing the praises of mouse research and rat research.
So, Chad, this is the lovely Neurolicia who's on. She is going to give us, we're going to learn a little bit about her background, about the science that she does, and then for Microscopy Monday, she actually made us some really cool images that we're going to be looking at and talking about what they are, and I am stoked to have her. Folks, she is, I guarantee you, she is coming, she is next on the partner push of, promoting science on this platform, so please drop her a follow. Her name is in the chat, or in the channel description today. Easy to click, easy to follow. We'll be doing hourly big shout-outs for her. She has a big event coming up in February. Is that right, Neuro?
Yeah, I haven't set the date because there was a fire in the building that my lab is in, so it's just, things have been chaotic. So I have to schedule a bunch of stuff that takes about a month lead time, and as soon as I can schedule that, then I can schedule the rest of my life. So right now I'm waiting to hear that the ventilation works so I don't accidentally knock myself out while doing brain surgery.
Oh my God. All right. Well,
important.
It's key to be careful. Yes. Okay.
Safety first.
Yeah, no, listen, at least they care about your ventilation. When my grad school, we had aspergillus floating down on us. And they, there's black mold. And they were like, yeah, it's fine. So, I put a bag over it, and then it, filled up with black mold, and I was like, here. And they're like, yeah, it's fine.
That's terrible. I thought it was bad when they did this carbon filter, and they were like, you don't need a fume hood. And I was like, I think we need a fume hood.
Moonrise_rabbit just subscribed for 16
facility,
months.
But it's in a heritage building at this older university that I'm at, and so the building isn't quite caught up with things, and our floors are brand new, but the 7th and 8th and all those floors are not brand new at all. So, yeah.
Lovely.
But, anyway.
And Moonrise, thank you for the resub for 16 months. And hello, Laura Gale, welcome in. Corn Relish, hi, Corn Relish, welcome on in, madame. So, we have Neurolicia on with us tonight. She is a streamer extraordinaire, a neuroscientist. She streams usually twice a week, Friday nights, and also a crossover on her other channel, Vulgar Science. And she was kind enough to come on today to chat about the science that she does with images. So it's our Microscopy Monday, but without the microscope. Welcome the heck in, Neurolicia. Could you tell us a little bit about yourself, how you got into science? Yeah, tell us about yourself.
So basically, I actually started wanting to be a counselor or a psychologist and work, at the front end of things, treating people with mental health disorders and stuff like that. And I did a little bit of that research earlier in my undergraduate because in Canada, you need to have an honors degree, which means you have to have lab experience in order to be able to go to graduate school to be a clinician. So I started kind of early on in that way working with humans and realized that working with humans has its own kind of particular challenges. Humans don't always show up. Also, when you're working with people in, certain states of mental health, disorders, that can be pretty distressing. On the, I was even just doing research, not treating people, but when you're treating clinical populations versus healthy populations, which is the type of research we were doing, that was really, I found, challenging for me. I was also really interested in working in an addiction sort of sphere, and because I wanted to move away from the human stuff, there just so happened to be a lab that was opening up that was going to be looking at addiction neuroscience, and I didn't know when I applied that they were a rat laboratory. So I aced my interview. He's like, "Oh, this sounds really great. Why don't I tell you about what we do?" And he's like, "Yeah, so it's on rats." And I was like, "Gulp. I don't think I can do that." For context, I'm the type of person, I've worked at like 6 different animal shelters. I have a dog myself. I've always had pets in my life. And I was like, I don't think I have the stomach for it. I'm like deeply humanitarian in that way, or animalitarian, whatever. I'm sure there's a word for it. But I talked to the person and they were like, give it a try. If you don't like it, you can stop doing it. Which is very true. And I actually gave it a try and ended up really, really loving it. And now I'm a rat enthusiast through and through. It's part of my brand. I have it tattooed on me. And, I'm 2 degrees later, almost 3 degrees. And, wouldn't trade it for the world. When rats are going to show up, when mice are going to show up. They have their own challenges, but, they're a nice happy medium for me. And I'd rather have someone like myself doing animal research that really cares about the animals and isn't like, it's just a mouse, which is the attitude of a lot of people,
Absolutely.
I would rather have myself doing this research knowing that, the dignity of these animals really matters, and that, we're going to make sure that their sacrifice to the kind of scientific world is going to matter, right?
I mean, that's something we deal with in insects too, and you could say the same thing. It's just a bug, but it's a world of a difference of how you think about the animal when you're actually putting it through, whatever experiments we're doing. And like you said, like addiction studies or dissections or what have you. Like, it's very much I think it's important to have respect for the animal, and that's something, Chad, we're going to be talking about it today. We've got some brain dissections. Pre-screen. There's no blood, no need to worry, but we will let y'all know when it's coming up. But one of the reasons why I love Neurolicia's work and how when she communicates her science is because of this element, that there is this humanity behind when you take over and you talk about the animals and like that respect for them. So when so do you work on both mice and rats?
Currently, I just work on mice, but my entire master's and undergraduate research projects were all on rats. They kind of have their pluses and minuses. To put it kind of bluntly, rats are a lot smarter than mice. They're just kind of higher up in like the phylogenetic kind of world, so they have a little bit more ability to be trained and trained quickly. Of course, they're bigger, they're more expensive, and they're a little bit more complex, so it makes it harder to have these genetic models that you can have in mice. So right now I work with mice exclusively. It's also something where you can't really cross over because rats will actually predate upon mice. So if you have the scent of rat on you, that actually stresses mice out, because if you put them together, they'll brawl.
Oh wow!
And no prizes for guessing who wins that one, right?
So in the animal care facility, there's a separate room for mice versus rats, presumably, right?
Separate floor, even.
Wow. Okay. So like really, like you can't have any crossover between them.
You really shouldn't. Some places just practicalities kick in. I know different institutions and stuff like that have different protocols, but in an ideal world, you don't even come in smelling like your cat. Like these sorts of things play into it. I actually just got a first author publication in press this week about just the effect of tester sex, is what we used in the paper, but like the presumed gender based on stereotypical gender presentations of the person, even that can have an impact on the behavior that you're measuring. And it doesn't have to be a complex behavior for us to be able to see it. It can be something as simple as like, how much force does it take to make the mouse pull its foot away when you poke it? Like, it can be that blunt of a measure, and even something that tiny can change it. So yeah.
So how does one even standardize your experiments when taking that into account? Like on the difficulty front, like is that hard, or is it enough where the experiments are robust enough where you can have these differences and it's okay, it repeats?
You know, there's a fine balance, I think. One of it is you can do statistical, kind of things to control for that. So you can keep track of when there's a different tester, and you can check and see if there's an effective tester. And if there is, then you can account for that as a covariate, which, gets into some really dull, numbery sort of stuff. But there are statistical ways to deal with it when you can't mitigate the individual differences between testers, whether it's because one smells like your cat or the other one doesn't wear deodorant or whatever. Those sorts of things you can account for after the fact, or you can just get it to be so that they all have the same tester, which comes with its own set of problems, right? Because you want something called inter-rater reliability, which means that different people see the same thing. So, if we're going to measure something and I'm measuring it using, centimeters and you're measuring it using, finger widths, we might not get the same measure, and that sort of thing comes into play. But what I would say is if you have an adequate sample size, the variability should wash out if you have enough replicate measures of whatever you're measuring, because variability and noise and that sort of thing will be overwhelmed by whatever effect you're presumably measuring.
And so I know one thing that we're going to chat a little bit about today is the differences between insects and mammalian research. And I think one thing off the bat is that replicate number. So you were even saying like rats cost more than mice, right? So all of a sudden this cost comes into question. When you're talking about replicate number, presumably you have to think about the cost for per animal, right? Like that has to go into the planning stage. What is like the difference between a rat and a mouse cost, and then how do you account for that cost when designing an experiment and having enough replicates that you are convinced about your finding?
So that's usually something that's determined by the principal investigator. So the actual dollars and cents of it is not something that comes into play in my kind of day-to-day or most people's day-to-day as a graduate student. And I'm sure it's similar no matter the model organism that you're using. I do happen to know, just because of my involvement in different kind of like managerial aspects of the lab, that, the difference is going to be like a matter of several dollars per cage, because usually you're actually paying for the cage of rats or mice, not for the individual mouse itself. So that's something that adds up when you have hundreds of cages or, something like that, because I'm not the only graduate student. So if I have 30 cages, and the other 5 grad students and postdocs and stuff have 30 cages going at any given time, that starts to really add up. And it's per day. So it's several dollars per day per cage. So I would say lots of, the operational bills for, just their mouse or rat housing budget would be in the hundreds of dollars per month minimum, if not thousands, depending on the size of the lab.
Yeah, and any kind of experiment that takes, like you said, multiple days, that's independent of keeping the animals alive, right, adds to it, and aging experiments, and it just kind of it's a lot really quickly.
Yeah, it does. It adds up, and it's something where I think that's why a lot of our science doesn't do these longevity studies. I study pain right now, and we have this nice idea in our heads that chronic pain is 3 months. That's just someone arbitrarily decided that. And also we've just determined, I put air quotes around that, we've just decided that it holds true in a mouse, a rat, a cat, a dog, and a human. It's all 3 months. But obviously 3 months to a rat that only lives for 3-4 years is going to be a different proportion of their life. But because of these costs and other kind of considerations, lots of labs stop doing stuff. So we don't get these longitudinal studies where we can get, richer data out of these animals that are giving, their lives and, that sort of thing to science. So I think it's our obligation to try and, I don't want to say extract as much data out of them as possible, because that sounds very like mechanistic, but it's our duty to make sure that their sacrifice is not wasted or willy-nilly. And I think, that's where the dollars should be spent if we're going to be spending them. Spend it on keeping them around as long as possible. And that's actually what our lab does here. We keep them until they die naturally.
Oh, wow.
If we can. Of course, when we need to take brain tissue, that there's practicalities, but if we can get these things, that's a rich amount of data.
So what is like the average lifespan that you'd be dealing with? Like how long are you looking at this?
For mice, a couple of years. I think the most that we've had is we're doing this in mice that are experiencing sciatic nerve or neuropathic pain versus ones that are not. And the difference is a matter of a couple of months on average. This is in a sample size of a couple hundred. And yeah, it, left unadulterated, they're probably 3 years tops, absolute tops. It depends on the strain of mouse. This is mainly what we call CD1s or black 6s. What the differences are is the color of the coat and the size of them and their feistiness levels for my purposes. But I'm sure there's more sophisticated differences in the background.
Cool. So before we get into the direct research, like I've got Neurolicia sent us a slide deck so we can look at some images. We have some paper she sent us, and then some brain slices. Can you tell us a little, like, working with these mice, like, what is your day-to-day like? Is there someone who helps with the mice care and you get to do the experiments? Like, what does a mammalian researcher's day look like?
So for the most part at the facility I work at now, it's a lot richer in resources of all kinds than the ones that I did when I worked with rats. So we have complete independent management of the colony by a university-appointed kind of veterinary corps that's overseen by the government of Canada. We, of course, all have to take our own ethical training and stuff like that, and mouse handling and husbandry and all of this. But the day-to-day care of the mice is taken care of by veterinary techs and overseen by veterinary, like full-blown vets. And then if there's any sort of concerns, they'll give us like a vet care card and be like, these mice were fighting. That's the most frequent one that we get. It's so funny. And we're like, what do you want us to do? Like, mice fight in real life, they're just, it's the brothers attack each other. It's always the boys. But
that is interesting though.
Trying to escape, I will say, so they each come with their own set of problems.
So, and it's true, right? Like with the female mice, if you breed them, usually the first batch of like babies they eat, right?
It depends actually. In captivity, things don't tend to operate the same as they do in nature, which is kind of funny. The contrivedness of their environment very much plays into how they're provided for. They have food ad libitum, they have water ad libitum, which basically just means as much as they want forever, kind of thing. Like it's full to the brim all the time. So you can see that like the drive to do any of this like cannibalizing of one's young, which is very common in nature, is going to be something that they just are like, I can raise these. They will definitely, if there's an unfit offspring, they'll definitely cannibalize it for sure.
So maybe it's a strain difference. I remember we were trying to do in graduate school a connection between fly and mouse, and the mouse line that they were using, it was like every time there was a first breeding female, every time she would eat her babies.
I think I've heard of it being to do with the age at which they have their babies.
Okay.
So I think it might be about like the primacy effect, like the first time that they have the babies, but it also could be young mums are definitely different mums in the maternal care kind of literature. There's definitely a little bit of experience, but there's also just age and sexual maturity and stuff like that. If they're just at sexual maturity, they're kind of like a teen mom sort of thing. So you can see where, just that life experience, if you downscale that and anthropomorphize it pretty heavily, you can kind of see where that would be the case. But we don't experience that a huge amount. We're actually doing a maternal stress study right now, because we found just in testing these mice that we were checking this chemo signaling study we were doing, which is just a scent molecule thing that we were doing independently. If we were testing males in the room that the females were being tested in for something completely different, we were looking at lactation and like, pain and stuff like that in pregnant mice. We wanted to use the babies of the pregnant mice because otherwise, again, that would be wasteful and not very dignified for the animal. But we found when we wanted to use them when they were grown up that they were acting differently. They were not habituating to their testing environment, which was very strange. So now we're actually directly looking into that and raising our own colonies for that specific study so that we control everything. And we're finding that there's actually not that much difference when we're trying to actually design it in. It's funny, but yeah, we're not having anybody eating their babies.
Nice. Hey, look, listen. I mean, it could also be right there. I know there's so much variance like between different sites too of like the gut microbiome, right? Like what, even though it's like standard mouse media, like one lab's mouse media might not be the same as a different institution's mouse media, and so it makes, like, I know there have been differences in results just because of something like that, and it's like you can't really necessarily account for it, and so it's interesting to see those differences. Yeah, and it was just funny. I didn't realize there was the boys causing trouble, the male mice like nibbling at each other, and that you get that data. Like, that's interesting on your day to day. Like, in this box we had some fighting, and I know you're like, what do you want me to do? That's what they do. But it's neat that you have that resolution, that you get that information from the expert like vet tech who's taking care of the animals.
Well, and we get to know them. They do have personalities. Rats especially have personalities, but I think you kind of hit the nail on the head with like the amount of richness that you can get in mammalian studies that you simply can't get in lower organisms, or even in non-organism models like computer modeling. A lot of people are saying, we have the ability to model a lot of these things, just using computing power. Why don't we just move to that? And I think it's because of this richness that you can get where you notice things. And if you're a good scientist, you're keeping your eye out for that sort of stuff, and you can make these amazing novel discoveries that you wouldn't have otherwise done if you weren't faced there watching an animal behave in a way that at least is a tiny bit relatable. Because I always say that rats are pocket puppies. They just act like little dogs for the most part. Like, they're very, very smart. They have different personalities and that sort of thing. So that's, I would say, the biggest benefit of that sort of thing is you can model stuff that's as close to humans as you can get without being humans or primate work.
Yeah, and I mean, that's always a big challenge anyway, right? That behavioral modeling going to a computer, because like you said, there's going to be variables that you might not account for, or things that you see that you had no idea was going to happen. Like, I know we had that when we were looking at flies, and it turned out if there was construction above and below us, the female's ovaries would apoptose, and so you'd have cell death, and we were measuring ovary health independent of the construction. It's like, so it's like, it's a frustrating on one side to have that happen, but it's like, oh, that's a neat bit of data that we didn't know before. That's a stressor for the animal.
Absolutely. Yeah. We actually have construction like vibrating the very core of this building all the time, which I'm like, we're testing these animals, and like, what are we going to do? Not test them? No, of course we're not. But luckily everybody's getting the same exposure, so presumably any differences we have aren't due to that at the very least. But
exactly. Yeah. So getting to your research, before we pull up the slides, you mentioned that you're looking at a connection between addiction and pain. Is that right?
So that's not actually my day-to-day right now. I am involved in a project that's looking at that. My master's and undergraduate work was looking at stress and addiction, which is kind of related to pain. Right now I'm looking, I didn't send any papers regarding that because they're not published yet. Hopefully soon. But yeah, so my day-to-day is mainly I do brain surgery on these animals, which is kind of where the microscopy that I'm going to show you comes in, where we inject a tiny bit of a certain viral construct that, we can get into the explanation of this. But basically, we take a little bit of a virus that we've engineered to make a certain protein that will make a certain receptor in an area of the brain that we can turn on and off at will using various methods. Sometimes you can use light, sometimes you can use a certain drug that you can give in the water or by injection. But the point is, if you think X phenomena is due to this part of your brain, I can do a little injection in this part of your brain and say, hey, when I shine blue light here, that brain area goes on, or that brain area goes off, and see if the phenomena that I'm trying to measure changes, and then we can say something intelligent about that part of your brain and its relationship to that behavior. So I'm using that, looking at how we facially express pain, or how mice facially express pain, as a proxy for the suffering aspect of pain that's the most important when we're trying to treat clinical pain in human beings and in veterinary contexts and stuff like that too. So we're basically trying to refine our ability to measure pain And yeah.
And so each one of these experiments that you're doing like that is just so chat's aware, like there are rules and regulations that are put in place to make sure the animals are not suffering, right? So it's not just when you're doing the brain surgery, right? They are anesthetized. They're not feeling this pain. If there is pain, there are like methods to make sure they don't stay in pain. So just like if you could just comment on that, just so the chat, knows like all the ethics that you need to go into just to be able to be in a position that you're in now. Like there's, I'm sure, years of training that you have, both physical and ethical.
Yeah, so you have to do a very big federal level governmental procedure training, and you have to recertify very frequently, and you have to recertify at each new institution. So, for example, I know how to do like full aseptic technique. I don't have to do that for these purposes because just we're not operating in a sterile field and all that kind of stuff. But they're fully anesthetized using isoflurane, which is the same sort of gas that you would, probably experience if you're an adult getting any sort of major surgery where you need to be under for a specific amount of time, like a longer period of time. Is in terms of their pain management. For the type of surgery that I'm doing, the incision is exceptionally small, and your brain actually doesn't have any pain receptors in it. So, of all the surgeries that you can do on the entire body, that's actually the least painful one. And I make a really, really I shouldn't continue without caveating that this might be a little bit not graphic, but if you're particularly sensitive, maybe mute for a second.
We don't have visuals going along with it, Chad. So
there are no visuals. I make an incision smaller than my pinky nail.
Oh wow!
Very,
so
very
super
I want it to
super
be
tiny.
as small as possible, so that I'm not disturbing them.
See, naively, I thought it would be like a big to get at like the region of the brain that you have to. So it's super super tiny. So this is like is this by hand or machine, or like how do you direct the?
So I sent you the slide pack that has a schematic of what it looks like. I don't know if that's too again, it's a cartoon of what the animal looks like when it's fully anesthetized and in this. Yeah, so this is them in a stereotax. So essentially what we want to do is we want to be able to position the mouse's head or the rat's head or the monkey's head or the human's head. This is how they do a lot of guided brain surgeries in human beings, is the same sort of concept. You want to make it so that the brain can't tilt, or the head can't tilt this way or this way, and it can't tilt that way or that way. So what you do is you put their teeth in a little thing, so that controls it going this way and this way. It makes it completely stable. And then you just put these little things in their ears that makes it so that they can't go that way or that way. And all of those things are fixed. So that makes it so it's flat. And then what we do is we have this really awesome book called the Mouse Brain Atlas that tells us where in the brain, you can see my notes, how much I use this thing. We can see if I wanted to go into that area, I know relative to a specific point on the skull, without even having to go into the brain at all, I can tell exactly where I need to go relative to this kind of North Pole, if you will. I know the degrees latitude and longitude, and we refer to them in anatomical terms, anterior and posterior, medial and lateral. But if you think about it just globally, how many degrees away you are from the equator, you can pick any fixed point, and with this mathematics and trigonometry, you can find where you need to go, and then you make the tiniest opening that you possibly can, and then you take a dental drill with a burr that is smaller than the tip of a pen, and you make a tiny hole in the skull, just enough to get through the skull and get to what we call the dura mater, which is one of the first layers of the meninges that you'll hit. It's the only one that you can see with the naked eye, probably in a mouse at least. And then I take a needle that is very expensive and very small, even smaller than, if anyone has needle phobias, maybe don't look at this. So this is in like microliters. I don't have the actual needle on it, but like this is how small this is. So if you were getting your COVID vaccine, a syringe like that would be fractions of the size of even the syringe that you would get for a vaccine.
Wow.
And then we put microliters, like you can't even see the droplet, into whatever area of the brain, and then I do a few sutures, close them back up, and the skull heals itself over, it recalcifies, and we're good to go.
Nice. So it's very standardized. You can do this the same way every single time, especially that North Pole position, and that means that other labs can be looking at the same positioning too, right?
Precisely. Nice. Yeah. You'll find these coordinates are actually reported in the documentation of various papers and stuff like that, and we do go off of other people's coordinates, because otherwise you would be going and wasting a mouse life trying to poke around and be like, okay, now I got to open up the brain and look at the brain and see if I got the spot, and oops, if I didn't, I'll adjust and then have to check again. So this is where collaborative efforts and publishing and sharing information and techniques and little tricks of the trade really works for us.
Nice. I've seen mouse papers with the methods, but I didn't realize how those coordinates were decided, and it's really cool that it's this standardized position, and every single time you know exactly where to go to. That's a very elegant way of doing it.
Like, look at how precise this is. I know you guys can't see the details. You can look at this on the internet if you just go mouse brain atlas. But this is how precise it is. You have like millimeter measurements at the top and down the side, and then it's relative to the stain of an actual slice of a brain. And then it tells you if I wanted to go to the, substantia nigra, doesn't matter if we know what that is, but this tiny, tiny part of the brain, remember, this is not to scale, obviously, for a mouse brain. You can go there because someone, Haxinos and Franklin, has done that work, where they section the brain 7 different ways from Sunday and make sure.
How is the equipment you're using extremely specialized then to be able to get to that part of the brain?
Yeah, so the stereotaxes themselves, that's the apparatuses that have the things, have little dials on them, and I use digital readout ones because otherwise you have to do math every time with like vernier calipers and stuff like that. It's a nightmare. But yeah, they're probably, in Canadian dollars, 2 of these is 30,000 Canadian dollars.
Okay, so yeah, very specialized. Like, this is not just I want to do a mouse experiment in a lab, we're just gonna pick one up for funsies. This is like a super, your lab is specialized on this.
In a facility of like 50 or 60 people that knows how to do this.
Wow. Okay.
Yeah.
Cool. It's very different from insect brain injections.
Yeah.
There is a machine that standardizes like how much you inject in terms of volume, but beyond that, like, I love how you were saying like there's a particular spot every time, that the incision size is the same every time. It's so standard versus like in insects, like we crack the skull with like a tiny knife wherever like you're aiming for the same spot, but it's by hand, right? And then you hook it up to the needle and then you just inject, and so it's not as elegant of a system. And I think, like you were saying, it's a higher order organism, so it needs to be this more elegant and like respectful almost machine.
Yeah, I mean, the tools that we have are only as fine as our dexterity can go, and as our dexterity can manipulate. So like you lose levels of granularity, like once you get to a certain point it starts to asymptote the amount of preciseness that you can get. We just we can split an atom by like running them into each other, and we need like a giant thing to do that, right? So hey Hannah, sorry, like I said, I'm at the lab, so
no worries.
A lab mate.
I guess important question from Gwen in the chat: does that book get updated often? Like how, or is it like pretty standardized at this point that it shouldn't have like a need for new updates? Like how fine of a mapping will you ever get? I guess that's also technology limited, right?
Yeah, well, and it's I guess it's experimentation and research limited, right? We're discovering, okay, we were like looking, say, even at the spinal cord. We don't even have to go to the brain, and this might actually be a good time to pull up the CFOS slides, the brown slides that I sent you, because at one point we were like, okay, this is the part where it's white matter, and this is exactly. So I don't know how like precise we can get in there, but we used to think all that stuff that kind of looks, all the dots that are kind of everywhere in there in this kind of like gentle U shape on each side. We were all like, okay, that's all part of the spinal cord. That's not wrong. Then we discovered something called Rexed's laminas. So these are the different layers of the spinal cord that have different cell types and cell bodies that are in each of these 5 or 6 different layers have, differing contributions to these ascending sensory signals and descending motor signals and stuff like that. And that's just at the level of the spinal cord. So as we do more of these discoveries, we might find, okay, this cell that looks exactly like this cell when we use this stain is operating differently. If I turn off just these ones, even though they look the same, they're doing something different. And that's how you find things that are like, dopamine receptors. We have 5 different dopamine receptor subtypes, and we don't talk about that in lay culture. Some of the dopamine researchers don't even talk about that, right? But there's 2 different groups of the subtypes, but you don't find that until you start to kind of twiddle around with them. Mm-hmm. And to kind of circle back to your original question, which is how often does this need to get updated? In terms of the actual anatomical structures, I don't think that they would change. It's the degree of specificity that we can get within them. So places like the amygdala have, the medial and the lateral aspect. And then within each of those, we've discovered subnuclei. And within the subnuclei, we've discovered even further subnuclei. And that happens as fast as science happens, which is slow.
Gotcha. And Maka, thank you for the 100 biddies. Thank you, Makawaka. Guys, we have a special guest today. This is the lovely Neurolicia coming to you from the research lab at an undisclosed location, because we're not going to be doxing her.
Funnily enough, we call this the bat cave sometimes.
There you go.
Because there was a bat that got into the old lab, actually, in our old building before we moved. It was getting renovated on one side, and it was just tarp open on one side, and there was a roosting colony of bats, and one of them got into the lab. And this was during COVID. It was the most exciting thing that happened to us for months. So now we just call it the bat cave.
See, no, that is perfect.
The bat cave today.
That is okay. So we need to make you emotes with like a rat in like a Batman outfit now.
Yeah,
I love it. But guys, please, we're giving her Neuro's getting the fancy shout out every hour as often as we can. But her name is highlighted in the bottom of the chat. Please go drop her a follow. She is an amazing science communicator, and it is an absolute pleasure for us to have her on today to talk about some of the science that she's involved in. Sorry, Neuro, I love to reset. I love resetting as we're coming new people in, that people know who you are.
Do. No.
So this stain.
I also can't. I can only see chat really small. So if there's questions or anything like that, or things that I can't see it. So
I'll interrupt you. Don't worry. What is this stain that we were looking at? So you were talking. Is this a cross section of the brain or spinal cord? Like what is this that we're looking at?
This is a spinal cord section. So you can see the darker areas, the kind of like darker, beigey brown. That's the inner part of the spinal cord, and so that's like kind of the gray matter, if you will, and then the white part is the white matter.
Oh, so it actually looks different. Like it's because this is is this by naked eye, or is there a stain here? Like I know there's the CFOS, but I can't remember. Can you see the difference between white and gray matter? Just without even like touching it up?
If you can get zoomed in enough for a spinal cord section is, I'm trying to think of something small enough. No, not even that. Not even as big as the end of like the tip of my pen here. It's even smaller than that. And when you slice it, you have to slice it quite thin. I'm talking like 30 microns thin.
So I guess that's a question too. Like you're taking these samples, right? You are not taking an entire brain and plopping it under the microscope.
No.
So when you say slices, can you like describe what are you doing to get these slices?
Yeah, so I would put a light content warning out there that this is, again, I'm not going to get graphic, but if anyone has sensitivities here, I would say that this is a good point to maybe protect one's own well-being and maybe mute. But I call it the forbidden deli slicer because it essentially is that. We are fixing the The only difference is in deli slicing, you are sometimes moving the meat on the blade. In this case, we're moving the blade on the tissue. So you take it and you super glue it, and then you take, and there's just a very sharp blade. It's called a sword blade. It's basically like a really fancy, like old-fashioned razor blade, and it's on a thing, and it's basically advances. We have a vibrotome, so it really, really finely zigs and zags back and forth and kind of saws through the tissue. There's also something called a microtome that is manually operated on frozen tissue, and then there's something called a cryostat that's also on frozen tissue.
So when you're doing the deli slicer, which by the way I've never heard it called that, I love that. We are stealing that.
Brings the right image to mind.
It really does. That is a really like spot on image. Do you just do it on the actual brain, or do you have to put the brain into like some resin and then are you doing the resin slicer, or is it both? Is it dependent on what you want to do?
It depends on what you want to do.
Okay.
It depends on the equipment that you have. Cryostats are probably the most expensive because you're doing it actually in basically a little freezer. You kind of are operating in a cold field, and then you have to cryoprotect the tissue because people are, remembering what happens to water or anything water related when it freezes, it expands. So if you have this brain soaked in cerebrospinal fluid, which is close enough to water that it operates the same when it freezes, you need to do something that's going to cryoprotect it. So we usually actually soak it in sucrose, but this is after we've done something called fixing the brain, which is essentially we just embalm the entire body of the mouse, just like funerary services do, to make it so that the tissue is rigid enough to cut, because an unadulterated brain of any type, of any organism, is actually really, really soft. It's like barely set jello. So you can imagine if you were trying to cut through something that doesn't have enough rigidity, even with a very sharp blade, it's instead of it cutting it, it's going to push it in and start to shear it and tear it. So you need to do something to firm it up. So that happens usually in most of the tissue. Some of them will block it. We'll put some gel around it to secure it. So this is kind of like the resin that you were describing. And then you'll slice through the resin and the brain. In the case that I do, I don't like to do all that kind of messing around. So you literally take super glue from the dollar store or wherever you want to buy it, and you super glue the brain in whatever orientation you want to slice. I usually do coronal sections, which means from the nose to the back.
Is there any reason for doing one over the other?
Yeah, so the way that the brain works with the ventricles and stuff like that, there's different areas in your brain. Your ventricles are what makes your cerebrospinal fluid, and they're just basically kind of holes engineered into your brain, and different layers and folds of your brain actually do have physical, literal space between them. And the orientation of cutting sometimes will make it so that those parts that aren't actually physically attached kind of are easy to tear. You can imagine that if they're 30 to 60 microns thick, it's already very easy to tear it. We have to take them off with a tiny soft paintbrush and stuff like that and put them on a slide. If you do a sagittal cut, which would be like from the tip of your nose this way, there's just a lot more holes in there in the mouse brain and
Gotcha.
the human brain, all brains. So most people prefer a coronal cut. The other benefit to a coronal cut is you can look at structures bilaterally. If you're looking at a slice, say, from my eyebrow to back here, a sagittal cut, you can only say something about the right side of my brain. You can't compare the right to the left unless you had two slices. With a coronal cut, you can look at that section and look at both left and right in the same plane. So that would be the benefit and why most people do a coronal slice.
That is really cool. I like that there's like all these different reasons, right, for doing it, and like this versus this, and you're looking at like both hemispheres, and is that like presumably you can look and see the differences in signaling between the two sides as well to see if it's symmetrical or non-symmetrical. Yeah. That's I love it when there's all this like logic built into the imaging style that you do, right? Because it's like it makes it like you're learning stuff by just describing how you're doing the imaging, right? Like maybe it's just me. I just get like stupid excited about that.
I think it's because we're both nerds and we both love science. We're like, boy, oh boy, is it nice to learn while you're learning.
Right? And speaking of learning, okay, so Peter has a question. Does it matter what kind of glue that you're using?
No, it's literally crazy glue, like crazy with a K.
Really?
Glue, and there's like some like little bug or something on it. I probably actually have some here. I'm not even kidding. I think I have a bunch. I hoard it under my desk. Yep. Crazy glue.
You're kidding.
Look at
No.
that crazy guy. It's literal just crazy glue from the store.
It.
Yep.
That's how. Okay, so that's how I felt.
A lot about being MacGyver.
No, because like, oh, we got a raid too. Free Heathen, welcome the heck in, Raiders.
Science stream, but we ain't bugging. We over here about to leave. You be chugging what we got. Now the tribes arrived. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
We got the Free Heathen here. Free Heathen, welcome it. Oh! And Derek Devin of Moko Made.
Subscribed for 19 months.
Resubbing for 19 months. Welcome the heck in. Free Heathen, how was your stream? I know you were doing some really cool 3D modeling. How did it go? Welcome. And I see Humbler John. Derek Devin of Moko Made, thank you for that tier 1 resub for 19 months. Welcome the heck in, Raiders.
Together, we can rule the galaxy.
And Bubble Fight Club coming in with the resub. Welcome the heck in, y'all. How was the stream? Tell me all
Bubble
the things.
Fight Club just subscribed for 4 months. Heyo.
Heyo, indeed. Travel the world, kicking off a hype train. Thank you, Travel, for that 100 biddies. Kicking off that choo-choo. And Humbler John as well.
Just subscribed for
Together, we can rule the galaxy.
Humbler John, thank you for the resub for 7 months. Folks, we do have a special guest on today. This is the lovely Neurolicia, a research scientist extraordinaire working on neuroscience of mice and rats. And we're talking about her work. And for Microscopy Monday, we're doing images that she took that are up behind me. So it's like a special guest star Microscopy Monday, folks. So Raiders, welcome the heck in. Thank you all so very much for coming in. Risto, thank you for the 100 biddies. Neurolicia, I'm going to leave it to you. For every level of the chew that we complete, you know, we do a raffle. Do you want to be the one? Do you want us to do it live when you're here, or we want to do it later? It's up to you, ma'am.
I don't know. Live while we're here would be cool. Like, why not?
Okay, I'm just letting you know you have the power.
I love having power. The best.
Guys, welcome.
Power of knowledge, power of science.
Oh, for science! Like that, yeah, exactly. Just like the emote. So Raiders, welcome in. My name is Balint again. We do research. We're research scientists. Actually, both of us, Neurolicia here too. We do research and science streams here on Twitch most days of the week. Today is our Microscopy Monday. Again, special guest. The lovely Neurolicia is here in the house. We also do on-stream model building, IRL fossil hunting, games, the science behind video games, science news, sci-fi science, all kinds of science, art, and more. So Raiders, welcome again the heck in. Thank you all for kicking off that hype train. Moo, hello. Welcome on in. DCing you today. Yes, we have. Oz, thank you for the biddies as well. Thank you for those 100 biddies. We are going to do a raffle as we always do. Neurolicia actually gets her own choice of stickers today because she is our guest here. That's one of the perks of being a guest on. You get to pick some stickers.
Water bottle that needs stickers. This couldn't have been more opportune.
She has graciously said that she will do the raffle with us. So for anyone who wants to win some stickers or magnet _point raffle, welcome on in, everybody. Neuro does not have to enter. She gets 3 of her choice because she is a special guest on the stream today. Guys, thank y'all again for the hype train, for those resubs. Appreciate that. Dacum, dude! 26 months. Dacum!
Dacum2 just subscribed for 26 months. Hello, science poetl and science fans.
Hello, Dacum. Welcome on, and thank you for that resub, madame. We will do the raffle. We're working on level 2. We'll be doing every level that we complete. We'll do a raffle for a sticker or a magnet. Again, welcome the heck in, everybody. Moo! Oh my God, Moo!
Woo.
Moo with coming in with 1,500 biddies. Thank you, Moo. Welcome the heck in, everybody. Again, this is Neurolicia. I don't think we can give her a fancy shout out yet, but for everyone coming on in, please, below the chat in the channel description today is her name. You're going to click on that if you're on the desktop, and you're going to go drop her a follow. Okay, she is having a big celebration stream in the month of February. We don't know yet the date. Moo! With 5 gift subs! Thank you, Moo, for another 5 gifted, getting us moving on along on our weekly sub goal. Moo with 5 gift subs to Krista Bellina, X Cassie Plockman's Mustard, Becca Crochets, and Winky Mawa. Thank you very much for those gift subs, Moo. And a raid. We are just going wildin' today. Raiders, welcome on in.
Science stream, but we
Hi, everybody.
Over here, but believe you be checking what we got. Now the tribes arrived. I promise that I have prescribed you vibes. The vibes we got are giant. Shout out to the stream for the raid. That's science.
Another raid with Crystal Cheesecake. Welcome the heck in, y'all. How was your stream? What were y'all up to today? And thank you for the gift sub. Humbler John to the Free Heathen. I appreciate the heck out of you. We have Steampunk Friend, Crystal Cheesecake. Hello, hello. Yeehaw, it's Addie. Welcome the heck in. The fairies are raiding. Welcome, y'all. Hogan, thank you for the 100 biddies. Oh my goodness. Neuro, we're wilding today, man. Guys, welcome the heck in. We have a special guest on today. This is the lovely Neurolicia. She's a research scientist working on mice and rats and the neuroscience behind pain, addiction, and more. And she's telling us all the things today. Oh my God, Jimmy.
Whoa, it's Jimmy B.
Jimmy, 5,000. What are you doing, sir? Sir! 5,000 biddies. Thank you, Jimmy B. Oh my God, y'all are absolutely wild. And thank y'all for those bits and subs. No, I don't, Jimmy. I have no idea what it's for because you got an engagement present that you shouldn't be paying for. He's very Oh my God, we're at a level 6. All right. All right, we got a lot of Neuro. You offered to do to count down the raffles, man. We gotta do all the things now. Cheesecake says it was fun. I did some art, drawing, and some friends into the Cozy Tree Club. Subs and other select people. Big. Oh, very cool. Crystal, if there's anything you'd like to share, let us know. I will happy to show it off, and that goes again for any of our raiders. Quick introduction again. My name is Balint. I'm 1/3 of SciAnts streams. The other 2/3 are my wife, Lita, and our daughter, baby Alona. Lita and I are PhD scientists. We are in molecular and systems biology from Dartmouth. We worked on insects, and today, Magister, thank you for the 300 biddies. We have a special guest on. This is the lovely Neurolicia. She is a research scientist who streams here on Twitch every Friday night before her lab had a fire. That unfortunately did happen. Hogan, thank you for the 300 biddies. So currently she's in a state of flux because, you know, there was a fire. What are you gonna do? Like, you can't. There's a fire, right? But she streams Friday nights and she takes Q&A from the audience, and I am proud to have a founder's badge on her stream. Yes, that is how cool I am, folks. I think I may have been the 2nd or 3rd sub on your channel. I'm just proudly saying that. She is gonna be, Chokes, I'm telling you, big time science communicator here on Twitch. Very accessible science-wise, very kind, beautiful puppers as well that makes appearances on stream. She is incredible. Please, please, please go drop her a follow if you have not already. Her name is in the episode description for today. I think we're gonna try to do the fancy shout out. 6 minutes. 6 minutes, and I'll be able to do it again.
You can think about it.
Well, listen, we'll get through the raffles, and then we'll do another fancy shout. Look at that. It's perfect time, right? Allegedly. Perfect timing. Guys, thank y'all again for the hype train. Exclamation point raffle to enter. We'll have stickers, magnets, sticker sheet, and a pin to be raffling off. And Neurolicia, after the stream, you get to pick whatever you want because you came on the stream and you're here to with your also.
It's my pleasure, honestly. You were my first science. I was like, oh, there's science on Twitch. I vividly. It was right around when what was it? One of the journals, Plus One or something like that, had whatever the one that doesn't have, you can't get rejected from, but you have to pay a bunch of fees. Whatever journal that was, it was when that happened. Is it Plus One or Science Advances or something like that? It's one of the.
It might be Plus One. It might be plus 1, yeah. There's also, like, the Frontiers ones do it, too.
Yeah.
Yeah. And, yeah,
It was really
ever...
so good that I got the guts to say something in your chat, and you were so nice, and I was like, oh, so people are nice on the internet? What?
Well, there are
Never heard of it.
smellies. There are smellies. But that's...
Oh, 100%.
That's why Neurolicia and we share a ban list to get rid of the smellies. Because there's a lot of smellies out there. But it's good to have, like, it is nice that there are people who are excited about science on the platform. And yeah, it's just amazing to have you. No, Humbler John, how dare you are not smelly. Stop that, Humbler John. Oh my God. He's so naughty. This Humbler John guy. He thinks he's so funny, counteracting me on that. No, and same with Moo. He's the guy. All those people saying this.
Sometimes I get so dank at the lab, I actually have body spray for making sure that I'm not a smelly ever. I keep it at my desk. How that affects the rats, I don't know. Or the mice.
Jimmy, you have a founder's badge, sir, and you have a how dare you suggest you're smelly, Jimmy B? Guys, this is the lovely art piece by our friendo, Crystal Cheesecake, that they were working on stream today. Crystal, that looks really cool. I like the all the characters, and in the background's a lot of fun, too, and especially like the bird. We have a lot of birding friends here, so this is, I'm very much enjoying this art piece. Thank you so very much for sharing and for raiding on in with your community. We appreciate you. And y'all, thank you for the massive hype train. The burb is the word, Humbler John. Thank y'all for that amazing hype train, folks. Queen Neuro has said that she will entertain a raffle. Again, ma'am, when is your heart out? I want to be extremely respectful of your time.
When do I have to be gone by?
Yes.
I don't really have to be gone by. I do have to be here back in 12 hours to help the girl that's here late, so she doesn't have to be here late tomorrow because she's having issues with her system. So I probably have another hour in me.
Okay. I just want to make sure. So that's what, like, 9.
Only because I have to drive home. If I was already home and my internet was working, different story. But now I have to drive home.
Okay. I just wanted to make sure, we're being as respectful of your time, because it's our pleasure to have you on, and I get nervous, ma'am. I get nervous. Okay, so would you like to run our hype raffles today? Whenever you say, we'll run it.
I say.
All right, first one.
We ran. In the name of science.
Saphira's Mama, 32. Look at that. Saphira's Mama, 32. You have won a sticker or a magnet. Congratulations. Saphira's Mama, let us know what you would like. Also, by the way, while we are doing these raffles, please go follow our friend
Science.
D-Senior today, a.k.a. Amooey. If you haven't already followed Moo, you're not doing life right. Go drop them a follow right meow. Saphira's Mama, let us know what you would like. Next up, Neuro, you tell me when we're ready.
Go.
Literate Ian. Literate Ian and Saphira's Mama with the winnings so far. Ian, let us know what you would like. Just up on the board, we got the stickers, we got the magnets. Indeed, Jimmy. Indeed. Newt, indeed. All right. Next up.
Okay. You're doing sticks, you said?
Well, we got 5 stickers, a sticker sheet, and a pin. I know. Supreme Doom, no worries. Let it. If later you need Saphira's Mama, if you need to wait a little bit to let us know what you'd won, don't worry. We're not going anywhere. We're not going anywhere. All right. Whenever you're ready, Queen Neuro.
Hit it again.
Hit it again. Supreme Doom 56. S8 for Saphira's Mama, you got it. And Supreme Doom, ma'am, you've won a sticker. I know, I said your name ahead of time, like confused, but I manifested that you win. I manifested that you
That's
win a
the power
sticker.
of science.
That's right. That's right. Let us know, Supreme Doom, what you would like off the menu. S8. Oh, look at that. Everyone's just on it. All right, 2 more stickers, and then we'll do the sticker sheet and the pin. Neuro, let us know.
Do it.
Jimmy B. Jimmy B 93. Jimmy B 93. Congratulations, sir. It's been a little while since Jimmy won something. I was getting worried that the system was avoiding him again. I don't like, you know. It used to be like Jimmy and Music Girl would be like most raffles, like it would be like, all right, they got it. And then it was just like this huge hiatus. Nightbot was like, no. And now we're back. Jimmy, let us know what you would like, my good sir. All right, 1 more sticker, Neuro.
All right. To end this Monday magnificently, for one final time, go.
Mama is a fan. I know, I'm disappointed, Music Girl. There were other raffles you've been entering, and you won nothing on those. But luckily, we fixed it. Jimmy, let me know what you would like, and Mama is a fan as well. If y'all need time to think about it, that's totally fine. You just let me know later on. We have 2 more. Neuro, we've got a sticker sheet. Purple Kevin, you got it. You got it, Mama. Purple Kevin for Mama is a fan. And, oh, S9 for Jimmy. Same. All right. Derek or Devin, if you two are here, I see y'all. Type exclamation point. Oh, what is my secret command that I put in for y'all? I don't even remember what it is. Oh, exclamation point Mokos. Exclamation point Mokos for Derek and Devin there. And also, chat, I think I can do this now before we do the final 2 raffles.
Who let the ants out?
Let's go!
No, did I missay? Here we go. Look, there y'all are. There y'all are. I have the secret command to bring up. They actually are on a billboard. They're on a billboard in the great city of Philadelphia. Right? And so there, I just have a button now that can come up. There's Derek, and then Dev's in the middle, and then there's Captain Moko on the side. And so now it's a trigger. I don't have to bring up the web source. I can just do whenever. I think is it just Moko that I have?
Let's go!
I think it might just be Mocha. But either way, I had to put it in because I kept having to share it with people. And it was important. It was important. It had to be done. All right, last two raffles. Before we do it, though, let me see if I can do this. Guys, please. There we go. Neurolicia's name is highlighted right now at the top of chat. If you see an empty heart button, you're not doing life right because it means you're not yet following her. Please, please, please correct it and hit that follow button. She is a neuroscientist. She's a science communicator here on Twitch. Y'all know I love our science communicators, and she is absolutely one of the best. She takes time. She's very, very good at explaining what she does in an accessible way. It is fun. It is welcoming. It is a safe community. Like, it is hats off a warm, welcoming place, and she does science communication proud. Please, please, please go drop her a follow. Okay. Two more to do. Sticker sheet. One sticker sheet and one pin. Let's do the sticker sheet first. Madame, you tell me.
All right, fire away.
Coffee rocks. Excellent.
Coffee rocks. Coffee does rock. I have my empty coffee cup from this morning sitting here, and I'm like, should I go make an espresso? We have like a fancy espresso in the boss's office, so.
Ooh, yeah. Then yes, without question. Coffee rocks, Madame. You want a sticker sheet? Although, if you don't want a sticker sheet, if you rather a regular sticker, you can get that as well. Let us know, Coffee rocks, what you would like. What if the heart is black surrounded by green? Your heart is breathtaking, Fishman. I'm not gonna even entertain that comment, Fishman. See, the people being just misbehaved, suggesting they're anything but breathtaking, and I don't even know what to do with it. I don't even know what to do with it sometimes. Magnet 1, you got it, Coffee rocks. All right, and Coffee, you had a question earlier. Would you mind reposting it as soon as we do the last run you had Coffee Rocks had a really good question right before we had all the raids come in. If I get this, can I donate the sticker to a nonprofit? So we can't send Peter the sticker to just a random nonprofit, but you can donate it to our school visits. When we do our school visits, it can go towards that. But this isn't a sticker, Peter. This is for a pin or anything actually off the menu. All right. If you're ready, Queen Neuro.
Drum roll. Go.
Music Girl 95, not rigged.
Not rigged.
Music Girl! I say not rigged because we were having the chuckle of Music Girl and Jimmy hadn't won for a little while, and they both won today.
What? Like I said, it's the power of science.
I know, Fishman, it happened. You did. I'm so sorry, Womp Womp. That is it for today. Music Girl, pin number 2. You got it. I know, Big Gamey. I'm sorry. There might be more. You never know. There could be. I know, Womp. I'm sorry.
Crying Antonia.
it's all the things. All right, so we had a question from Coffee Rocks earlier this evening. Coffee, if you have it up, it was people are raging here.
Explaining photosynthesis to you when you were 12, but you're adults now, and this is an actual crisis. Got it?
I have lost the question. It was right before all the rage. I appreciate you, Ian, but I think it was the difference on like accessibility to the brains. But we'll wait for the
Barbecue sauce.
the reposted comment from Coffee Rocks. I know, Peter, we may have gotten a little derailed here.
That's fine. We love a rabbit hole. Even if a raffle hole, if you will.
We did.
It's my favorite one.
Ma'am, you know we got you now on video doing it too.
Yup, and free reign. That's hardly the worst thing I've done on the internet. You see my
Okay,
screen?
if we have your permission,
Marvelous.
mods, please clip and let's put in Neuro and see
Virgin
what we
dinosaur.
move.
Dinosaur virgin. Virgin dinosaur. Dinosaur.
Are we mods? Can we do? Please. So we got like it's just growing. We've got now we'll have a 4th Ulu that we can put in and
There's
that,
5.
Picture
5 Kevins.
Risto doing it behind me on your screen, and us doing it together, and he's my husband.
all the Ulus together. That's true. We can have a variant. We have double Ulus.
Science, especially the science streams.
So I think we'll reset. We were talking about the imaging. We were talking about
Balint the science guy.
Yeah.
Balint the science guy. Science rules. Balint the science guy. SciAnts is a partner on Twitch. With lovely wife Lita. Balint the science guy.
All right, perfect. All right, we're back now. We're back. Oh no, we're not. All right. Guys, Neuro's got to go home soon. Neuro's got to go home soon. If we want to learn about the amazing neuroscience that she's doing, we might have to calm down. We may have to calm down, folks. Also, Professor Canuck, welcome in.
A center for ants.
Title System first time chatter, welcome. We are a science communication channel here on Twitch. We have a guest today. She is the lovely Neurolicia. She is a research scientist focusing on neuroscience of rats and mice. We're doing a little bit of a compare and contrast to insect neuroscience, and she's been telling us techniques that she's been utilizing to ask basic fundamental neuroscience questions. She's also a Twitch streamer. Please go drop her a follow. Her name is in the channel description today. And we're just looking at some of the imaging that she's been able to do. This is in particular a nerve cord, spinal cord slice. We were talking about, even you can see gray and white matter just by looking at this image and the stains that she does, which has been it's been really cool learning about some of the methodologies. And actually, Neuro, we've had questions in the chat of already if we can have you back. When your addiction papers drop, but I think also just in general, wanting you back to be able to chat about and like your research. I think everyone's very, and also thank you for putting up with our shenanigantery.
I love the shenanigans here.
Coffee Rocks is wondering, is the difficulty of brain surgery in insects with relation to the circulatory system, is rat surgery easier than mice because of their size? So I guess, okay, so is the rat surgery easier because of the mice just because of the size, or is the resolution at which you're able to operate like so fine that it really doesn't matter?
It depends on the type of surgery. So when it comes to brain surgery specifically, I'd say easier to hit things that are bigger, right? So, you know, at kind of a, you know, really gross, zoomed out sort of level, it is easier. But it's also got its own practicalities. Rats are bigger. You need bigger things to just be able to do it. You take more equipment. It takes more time. You know, there's just a whole bunch of other different practicalities. There's things that you straight up can't do in a mouse that you have to do in a rat. When you're doing particularly the addiction studies, lots of the addiction research to this day, or up till now, has really focused on intravenous self-administration, which oh, baby, I love 5 of them too.
Too many.
I wish Hoon was here. I would bring Hoon up, but she's not. Anyways, in the addiction research world, we almost exclusively use rats until we started developing this mouse oral self-administration. It's intravenous self-administration, which you can imagine is very difficult to do because we're not giving it to them like, you know, a typical user that was an intravenous drug user would use it and doing syringe into their, you know, ulnar vein or something like that. We have to put an indwelling and long-term catheter, and we actually catheterize their jugular vein, which is exactly what it sounds like. It's just taking a really tiny tube and putting it in there so that when they get the drug delivered, it has a little port that comes out on their back that you connect. That is something that people have tried to do in mice, and it's just simply too small. You simply cannot do that in mice. People have tried. There's, I think, 2 or 3 papers out there where they do IV self-administration, and you can only do it for a very short amount of time because just the tube gets clogged up because it's made out of, you know, biocompatible plastic instead of actual tissue. So it doesn't have the same, you know, phenomena that way. Brain surgery, you don't need a scope as much for rat surgeries. I barely need one for mouse surgeries, but, and then in terms of how that relates to insects, I've never worked with insects, so that's a you question.
So when you're saying like that you don't need the microscope, is it that you're just like by eye you can tell where to do the cuts?
Yep.
Wow.
Yep.
And do you think, is that just like you've worked with them so long that at this point it's just second nature?
Well, so most of it's guided by, if I didn't send you an image of this, but there's the top of the brain. I wonder if there's an image in here, or the top of the skull. The way that your skull is, our skulls, rat skulls, mouse skulls, cats, rats, dogs, all of it. It's not a solid shell like a ping pong ball. It's got flexion points, just like a bridge does, so that when it has any sort of impact, it can kind of absorb that. So there's actually, they call them sutures because they look like actual sewn sutures on the skull, where at the center point, you have what's called the mid-sagittal suture. And that basically is a point at which your skull fuses, and there's a line that stays pretty static. Like, it's slightly different, but the variance is small. And then there's a coronal suture that's anterior and a posterior coronal suture as well. So you basically have these kind of like 2 almost windows that you could open. You wouldn't, because that would be very traumatic to that area. But you can go relative to kind of that North Pole point that I was talking about before and go a certain latitude and longitude from that point. And just knowing where you're going to be doing that and knowing approximately where that sits below the skin tells me vaguely where I need to go with my incision. And then I use just very, very small scissors and I make the incision as small as I can. And then once I'm in there, I find that spot. It's called bregma, which is like a Greek word. I don't know what it actually means, but there's a specific spot where that mid suture and one of the coronal sutures meet. It's the crosshairs. And all you have to do is zero down on that crosshair and make that the 0 point. And then anything you add or minus forward or backward, you can go to that spot, make that tiny hole I was talking about before with the dental drill. We literally use a dentist drill. And you make the itsy bitsiest hole. And yeah, all it needs to be able to do is pass a, like, I think a 36 gauge needle, which is so tiny that if it had any resistance stronger than a brain, it would bend.
Wow. And so I guess also touching on Coffee's question, veins, arteries, blood when doing this kind of brain surgery, is that really an issue? It doesn't sound like it is, right?
If you're doing a good surgery, there should be almost no blood. Of course, there's going to be individual differences in where the vascularities lie, and your scalp is relatively, well populated with capillaries and stuff like that. But imagine our capillaries are tiny, and if you bust a capillary, you're not going to bleed out unless you have hemophilia or something. And a mouse's is scaled down that much more. So if you do, typically you're not going to notice it. You might get like a little bit of kind of like plasma-y sort of thing, but I would say I use like a Q-tip worth of absorption, and it doesn't even get red. It gets maybe a tiny bit pink kind of thing, and that's the most blood I get, unless there's just for some reason a vascularity there that's major that is out of the ordinary, and then maybe I'll go through 3 Q-tips.
So so I guess then on that point, there's not really any difference between the insect open circulatory system or the mammalian closed. Like, it's not really enough to take into account, like, us being affected in how we're doing the experiment.
No, not for brain surgery of the stereotactic variety that I'm describing here. For jugular catheterization surgery, you're going right into their circulatory system deliberately. So there's a lot more considerations there, and funnily enough, it's actually an easier surgery because you don't need as much specialized equipment. So in a lot of ways, you can knock one out in like 15, 20 minutes if you're well equipped to do that. Whereas these brain surgeries take hours because you just have to go really slow when you're in the brain.
Cool. I like it. So people want to see more images, but I think a really important question that popped up in the chat before we continue and look at the other images comes from Glued with Gold, is how different are the brains of these animals compared to humans? So like, how easily is the mouse research or rat research you're doing translated to humans?
That's a magnificent question, and one that the very short answer is depends on what you're talking about, right? So when it comes to the brain, what we know is there's more kind of evolutionarily early. We talk about lizard brain and your instincts and that sort of stuff. And this is, your fight or flight reflexes, these things that are kind of deeply ingrained, that are phylogenetically conserved across species, is the fancy way to say we all are scared of things that can hurt us or make a threat to our survival of any variety. A mouse is going to be scared of anything that's bigger than it. We're supposed to be apex predators, but we're still scared of things that we should be scared of, right? So those parts of the brains we think are quite a bit more comparable than, say, things like cortex. So we talk about, having our frontal executive function area. That's something that's unique in some people's views to humans. At the very least, it's unique to primates, we think, in terms of, our ability to think about things that are quite complex and plan and, have those sorts of higher level thoughts. I don't know how well we can prove that is the case, but, that's the state of affairs in the general scientific belief. I would say even with those evolutionarily earlier things like fear, that context plays a lot into it, and I talk about this a lot in my, thesis defenses and discussions and stuff like that. The fact that my anxiety about passing my, thesis defense, or my, excitement about coming on your stream is very different than a mouse's nervousness about a shadow going overhead thinking it's going to be eaten by an eagle. The flavor of that is different. Where it activates in your brain is the same. And even like the substructures are the same. Even the cell types are the same. And that's the beautiful thing, is we can up-translate it that way, and that's pretty solidly translatable. What isn't translatable is how that kind of fits into the broader milieu that you're experiencing it in, right? So I think it's similar enough that it has utility, but not so similarly that we should just walk around thinking that mice are little people.
And even like with the similarities in the brain regions and cell types, there's still going to be variables that we can't necessarily account for. Right? Like if we're doing a drug screen and it works in a mouse, it doesn't necessarily mean that it's going to work on a person. But it's like you said, it's a model organism, so it's informing us about what we're learning and how we can learn something.
Absolutely. And I mean, the thing to keep in mind is mice and rats and animals are very robust. They're designed to be scrounging around on forest floors and stuff like that. We are not. Like, I mean, maybe historically, evolutionarily far earlier we were, but we've gone soft in the last couple million years. Maybe even longer than that. But anyways, I'm just being in jest here, but yeah.
Well, so and is it true? So what I've heard on mice, and I guess tell me your experience too, is that a lot of the mouse lines that we have were even bought at like markets, right? They're highly inbred, so they are also not necessarily ones to, if you just release them, they might not survive in the wild. And you talked about like memory issues too, like some of those mice. I know like there was the famous study where it was like, oh, we think we found a learning and memory gene because it's not responding to the sound, and it turned out later it was deaf, right? And that was just a thing in like the genetic background. So it's still weird, right? Of like how much we know and like what we can translate, and like what's even at the beginning of the stream we were talking about what's contrived, what's not contrived, right? Between like how we set up the experiment. So it's like we can learn a lot, but there's still a fair bit of how you interpret that to a human. Is that fair, would you say?
Yeah, absolutely. I think, we all have to, check our, hopes and egos and stuff like that with regards to science. It can do a lot of things, but we need to have interdisciplinary things where, I'm not using mice to solve mice problems. I do want to solve mice problems, and when I research pain, generally speaking, the problems that we're solving that are designed to be models for human problems are also solving mouse problems, but, I need to realize that this is at best a proxy, and that I'm doing this not to do this kind of self-contained, mutually exclusive experiment to find out the answer to the question. I'm trying to find this out so I can hand this to a human researcher who knows how this operates in a whole bunch of different ways that I can't understand, because you can't be a specialist in everything, and say, hey, here's some knowledge. See, does that work with your system? Are there considerations I hadn't thought of? Are there things where this wouldn't necessarily even matter to, like, we don't talk about prey drive in human beings because it just really isn't a thing, right? But that is a huge thing that, for almost all other animals. And it takes discussion and collaboration and critical thinking of the nature that, your channel curates and that sort of thing, which is why science communication is so important, right?
I think really well said. Really, really well said. We have, before we get into some of the images, Moo was wondering if you use surgical loops at the point to work with the smaller components of the surgical process.
Surgical loops?
Loupes?
Yes, yeah, that's like the French Canadian term. We call it a loop, like an eye loop, like a like a monocle or a pince nez or something like that. It's a loop is just the French word for a like handheld scope. Like
okay, great. I was like, what is this?
What's like the inspector thing, like, that an investigator uses?
The monocle?
Which is a magnifying glass, right?
Or like a monocle too, right?
Yeah, I mean, a monocle is the way, like, yeah, I have actually magnetic ones that can be stuck to the stereotactic stage, and but I usually just hold them because I find it way funnier, and also then I can manipulate it in a different way, but it's on like a little bendy arm. It's quite funny.
Okay, cool. And so you do have to use that for the, but you said you can also do it by eye at this point. That you're just like the prof.
Yeah, I check it with the loop.
Okay.
I check it with the loop, but once you see the top of a mouse skull, I like if you even got a schematic diagram up that was not that, and if you just Google Bregma mouse, if you know like chatters want to do that, if they want to risk their own visions of things, you should just get it's pretty black and white, like not black and white, it's kind of like fleshy colored and white, but
I like that.
it's hard to not see. The thing that you want to do is, again, because as we get smaller, you need to be more precise. Millimeters and fractions and like tenths and hundredths and thousands of millimeters matter. I go to the hundredths of millimeters measurement. If you are off where you zero, then everything's off, because again, we're going by the map, the atlas of the brain. So getting to that one specific point, that's kind of the deal breaker. So that's the only time that I ever use the loop. I kind of go to the point with my eye, I verify that I am indeed at that point, and then the rest it's not automated because I have to do the twiddling and stuff like that, but all I have to do is move the forward dial to move it forward and move the backward dial, and so on and so forth.
So again, it's just like hitting that right north pole. Yep. After that, you're pretty much safe. But if that initial step is off, like you said, your whole map of where you're going to be injecting is off.
Yeah, if you put the North Pole in Greenland and you said go X kilometers south, you'd end up in the ocean instead of Canada or where, you know what I mean? Like it's quite literally, that's like a really apt kind of analogy for it. If you start out in the wrong place but you do the right steps, you're going to end up in the wrong place.
It's really cool that it works that way and it has that resolution, because like with the insect neuroscience, if you're trying to do the injections or what have you, it's like you're in like an area, but it's like a lobe, not like a distinct region of the brain of where you're injecting. I think part of that is, like Coffee said, is size and scalability, but it's just neat that you have those tools and the resolution to be able to get at that. And then we had a follow from Tidal Systems, thank you, and said, being that we are a dissociative identity disorder system that advocates for mental health, it's neat to hear how animals may think. So it's like how you were explaining, like, why it's being utilized as a model organism and the benefits of that. I think it's really remarkable that, there is that. It's hard to not anthropomorphize, but at the same time, you are getting information that informs us about humans.
Yeah. Well, we try and model it as closely as possible, right? Like, even I was discussing the addiction modeling that we do when we do self-administration, and how we were doing it intravenously. And, I particularly have an interest in opioid analgesics. And yes, people do intravenously use that notoriously. We talk about intravenous heroin use and stuff like that. But for pain purposes, most pain patients are not using intravenous drugs except for maybe peri-surgical times. Most people are using them orally. And, using a mouse model is going to give you, way more control over genetics and stuff like that can be way more informative about genes that contribute to certain behaviors. So having an oral self-administration model, I developed here, basically you just make a solution with condensed milk, sweetened condensed milk, and you dissolve some morphine in it, because morphine is quite bitter, unadulterated. And so you just make it sweet, and you deliver a little, like, microliters of it into a tiny little dish, and they can come and they can give it to themselves. And you don't have to do any surgery to them whatsoever. You can just get a certain breed that, is a knockout for, I don't know, D2 receptors, which is a subtype of dopamine receptors, if we think dopamine is the big thing, which everybody does. But, if we think that that's the thing, we can knock it out and be like, okay, do the ones that don't have dopamine receptors act differently than the ones that do? And you don't have to put them through anything. You can just say, how much do you want morphine? And some of them will respond 500 times and some of them will respond 5. And if those groups are different enough, then we can say, hey, this is probably something to do with this receptor.
And is that, Do you find, in terms of behavior, is it easier to interpret if you don't have to do the surgery? Like, is the surgery something that introduces variation a lot, or is it the technique good enough where it usually isn't an issue?
So this is where it would be appropriate to have a sham surgery control group. So in the kind of broader world of just general surgeries of any kind, you would have a sham surgery where you would open the incision spot and close it back up and not do any of this sub-manipulation. So then the effect of the surgery itself should be ameliorated because it should be hypothetically equal across groups. For the purposes of the brain surgeries that I'm doing, we actually would still want to look at those brain areas. So we don't really have a completely unadulterated control because I think that would be a waste of an animal life, frankly. We have ones where we inject a fluorescent protein so that we can compare when we're looking at images like this, which is a CFOS image, it's not fluorescent. But, you know, if we wanted to do it in a fluorescent animal or do it with fluorescence, we could say, hey, these cells that are fluorescing here are only fluorescing when they have the virus that I'm injecting into them. And here's them when they just have a reporter tag on them, and be able to compare those differences. And that's where the glowy ones that I sent you might be useful here, because that's how we overlay the images and compare and contrast, which is really cool. So this image is a DAPI stain of a part of the brain. The main thing is that DAPI stains cell bodies. So this just tells us any cell in the brain that has, I think it has to do with the endoplasmic reticulum in the mitochondria. If it's got that, then it turns blue. So all of these are tiny cells. And that's interesting and cool, but it's more interesting and cool when you look at just the red one, so not the overlay. Okay, so this one, these are showing, these are microglia. This is the particular stain is looking for a specific type of microglia. It's associating with calcium in this case. I don't really know how any of that actually works in the background. I just know enough to sound dangerous.
Doesn't sound dangerous.
To be dangerous, to sound cool. But the power comes when we overlay those things and we can say, hey, this one that's got DAPI that says this is a cell and not just some speck, and this one that's got the red that's got glia, I'm looking at a cell for sure. And this cell is a glia because it's got this tag and this tag. And that's where it becomes really powerful. This is within an animal. Our control animal that we would do the surgeries on in this case would have a probably green or yellow fluorescent protein in place of the red ones, and we would see none of the red. And we would want to see, you know, are we talking about similar areas? Are things kind of populating in the same way? And we would want to be able to compare and contrast those two groups to say, hey, our virus worked. Here's what it looks like when you don't have the virus. And to show that we didn't change just general functioning in that area, that we didn't just lesion the area because it's toxic, you know, or something like that. So we would have active controls in this case.
And then the control from chat, Smikes was wondering if you have, like with the addiction study, right? For example, you're mixing it in with the milk, as you were saying. Presumably there's a control group that just has the milk as well, so you're able to delineate if the animal is just going for the milk versus if it's actually going for the morphine.
Yeah, so that would be an appropriate control if the interesting thing was about whether or not they were getting morphine as a motivator. In the case of the study that I'm describing, and I didn't actually explain it at all, so it makes sense that this question is coming up. Our question isn't whether mice in pain, actually it kind of is, but we're not really concerned about whether they would choose morphine or just condensed milk. Those studies have been done, and there are people that are looking at that. What we're looking at is if you give everybody morphine or the opportunity to take morphine, what are the conditions by which that changes? And in this case, we're looking at, relapse and how different quitting patterns play into things when you're in a pain state. So whether quitting cold turkey if you're in pain matters, sex differences and those sorts of things. So again, they're all going to get the opportunity to take morphine. In an ideal world, you would also, do the control study of, just condensed milk, but that's not really the question that we're trying to answer. And that's where it circles back to those ethics. yeah, we could do that. And that would be perfect science. That would be an A+ science to do every possible control. Would that be A+ ethics in animal research? It would not be, because if you wanted to match your N, which you have to have a pretty high N to be able to get variability in these behavioral types of studies because of individual differences in those personalities of these mice, you would need to do another 60 of each type, of each group, just to say something that we're pretty sure we already know isn't really answering our question, and other people have already kind of studied. So that's where you have this balance of, do I want to use these mice for this purpose?
And that's very different from flies, where you can justify the repeat, right, every single time, because it's not...
Exactly.
Like the numbers are easy and it's so quick to do, and then all of a sudden, like with the mice, like you're saying, it's very important to bring in those, like, it's that unique ethical consideration.
Yeah, so there's something called the 3 R's in animal research. So it's kind of like reduce, reuse, recycle. So it's pretty easy to remember, but it's replace, reduce, and I can't remember the other one. But the general idea is, if you can use a lower order organism to answer the question adequately, do so. So if you can do it in flies, do it in flies. If you can't do it in flies, do it in mice. If you can't do it in mice, do it in rats, and so on. And so obviously the holy grail of most of our questions is human beings for neuroscientific and psychological research. But most of this you can't do in humans. So then we're like, okay, chimpanzees. Again, maybe if we go to the lowest order one that we can answer the question in. The other thing is reduce the number. Do it in as few as possible. Do your statistics well, do your power analyses, and see how many is the bare minimum number that I need to be able to answer this question, assuming that you do things properly. And then reduce, replace, refine. So refine is where you want to, this is probably the one that has the most area for interpretation. So a lot of people are like, well, why do you sack the animals when they're at this point? Why don't you do XYZ more to them? And the correct answer from my perspective is, sometimes they meet their experimental endpoint sooner than they meet their ethical endpoint in a lot of ways. Sure, we could keep them around for a long time and take their brains when they naturally die, but then any of the changes that I'm seeing, I can't say for certain are because of my manipulation and not because of some artifact of aging, or artifact of aging after having had the manipulation that I did to them in the first place. And in order to find out if that's the case, I would need to do both. Therefore, to satisfy the reduce the numbers to the bare minimum, to answer your question, it would actually be better to refine it down to just enough of their life to answer my question, and not so much more that you're confounding your original question and building in new things to have to figure out that's going to use more animal life. And it starts to get a little hairy at that point. But
yeah, and I guess the other thing too is, if you keep them around longer and you were to do other experiments on them, that could also be a confounding variable, right? Like,
absolutely,
everything that you've done before is going to affect them, which I know is an issue in chimp studies, but like,
yep,
you don't have access to thousands of chimps, right?
Yeah.
And so you get that like constant effort of that, but I like how you're framing it, and I really appreciate how you're talking today to us about the ethics behind doing this, because I feel like again, why you're such a good representative for science is that you are accounting for the animal's life, and you are thinking about it, because there really is sometimes this element when you're like just looking in from behind of like researchers not being aware, and you're not made out to be like you're taking care of the animals. And I really like how you're talking about us about this. I really appreciate it. Some people are continually interested. I know we've been rabbit holing a ton about the work that you do, and we have these slides, and one question about some of the slides that you do as well, like what you're working on. Maybe we can dive into a little bit about this with the facial expressions, is sex differences, and if you notice any sex differences between males and females, and how that might affect your work too. So I don't know like how these slides factor in, but I'm happy to take us where we are going, Neurolicia.
Yeah, So this slide is really interesting because the mouse, the white mice on the side there, on your right side of your screens, I guess, is actually a scale that was developed.
What does that mean?
You know, in somewhere that's very close to, like, in the same facility and stuff like that by people around here. Which is pretty cool, and it's something that's used the world over now in veterinary contexts. This is the mouse grimace scale. This is how we determine. This is actually on science diagrams that look like, you know, internet posts, the bad word posts.
Yeah. It totally. Or like T-shirts, right? Like where it's like.
Yeah. These are ones that you'll find on meme pages out of context. So this is something that we use now when we treat animals when they come in, because any sort of nonverbal human being, animal, anything like that, you know, they still facially express, and we express emotions on the face all the time, whether we like it or not. And the valence, the positivity or the negativity of those emotions doesn't really dictate how strongly they're expressed. We don't express negative emotions more strongly than we express positive. And pain as an emotional expression on the face is something that's kind of just starting to be recognized now. We used to think of pain as a very sensory experience. And then now we're realizing that there's actually two kind of separate parts of it. And that one of the ways to measure particularly the emotional component of pain that is conserved across all species, including humans, is that we all do this. Ouch. If you stub your toe, you will scrunch your eyes, you will scrunch your nose, you will bring your lips up, and you'll, you know, probably curse or something like that. And lo and behold, mice, any animal that can make a facial expression, I think they've seen it down to, like, I think a lobster is the most tenuous one that I've seen, which I don't think lobsters can make facial expressions, but they'll, like, do antennae things. I haven't looked deeply into the lobster literature, but I think there's 13 species. There's a horse grimace scale, a seal grimace scale, you know, and we use this in human beings as well. And it's a robust research field, and I think that speaks to this translatability, and that there's certain things that if you allow yourself to kind of zoom out, talk to other researchers, how this scale got developed was by talking to human researchers and being like, you know, we notice when we think mice are in pain, they're doing this thing. And it's the same facial musculature. It's the same, you know, they move their whiskers. We don't have whiskers, but there's lots of stuff that stays the same. And it's true for all different types of emotions. And this is just basically what this slide is showing.
Is this a tool that you use in your...
Yes.
So is it, naive question, and also Glued with Gold says mice have been known to yell Jesus when they stub their toe. GG's Glued with Gold. How subjective is this? Like, are you scoring it by eye? Is it something that you can get a machine to do, or is it like just so obvious that, like, That's
not a silly question at all. That is a question that I got pummeled with at SFN this year for 4 straight hours. So you were right up on.
I am so sorry to make you relive.
Literature. So as you can see, there's 3 columns. They're across the rows. The 3 images of the mice are the different areas of the face that we're looking at. So in the first one, we're looking at the orbital tightening, how much they're squinting. The next one, we're looking at how much they're scrunching their nose, so how prominent their nose bulge is. The cheeks, how much the cheeks are puffing out. Each of those are the rows. And you can see in the columns, there's not present, moderate, severe. So it's a 0 to 2 scale. And it's kind of relative to the max. So your eyes can only squint so much before they're shut. Mm-hmm. And so if it's pretty close to shut, it's a 2. If it's partway in between, it's a 1. And if it's not at all present, it's a 0. This is something that we do manually. It is a huge bottleneck. It takes a lot of undergraduate students. I have 5 pretty much every semester, sometimes 6, that are doing this and taking still images of a video and doing it manually by cropping every single one of them out. It's a nightmare.
And they look at each one of these features, is that right?
So we actually have a separate person doing it that's blind, but yes. Yeah,
okay.
A person is going through these slides. It becomes pretty quick once you're quite good at it. You can, it's hard to unsee once you see it. So it becomes pretty quick, and we've got, you know, some pretty good specialists because I'm at, you know, a facility that specializes in these various types of techniques. There's a group at University of North Carolina, Chapel Hill, run by a guy named Mark Silka, who has automated this using something called painface.net.
Okay.
I don't think that it's actually accessible to the public, but you can contact them for access if you want to. And it's trained on black mice and white mice, and it should, in theory, be able to do this with machine learning. The problem is mice are moving around. We're not telling them to do anything, and frequently mice
Together, we can rule the galaxy.
They'll kind of seclude themselves and obscure part of their face, which is why I'm looking at lateralization. Is the left side and the right side the same? And can we get at just certain parts of the face and say, as long as we can see the eye and how much it's squinting, is that going to give us a good proxy measure of what we would get at this more fine-grained level?
So this isn't, they're not immobilized, they're like running around in their cages. There's multiple in a cage?
They're not in their home cage.
Okay.
They are in little cubicles. We take them out and we video record them. So that we face. There's a camera basically about that far away, and they're in a cubicle. I don't know, about that big. They can enough for them to point either way.
Yep.
Kind of thing, openly and freely.
Is it just one per these little cage?
Yeah.
Okay.
Each gets their own little cubicle, and then they go back into their home cage. We usually do it 4 at a time because there's usually 4 per cage, but that's just an arbitrary thing that we chose.
So the counter doesn't have to parse out if this is mouse 1 or 2 from like one image. Instead, it's just like they have 1 per cage. You can monitor.
4
record.
cameras, 4 pods. Yep.
Cool. Okay. Nice. And it was
It doesn't
cool.
have to be that way. You could theoretically zoom it out. What you need is the resolution of being pretty close. So we have HD cameras and we have them quite close so that you can get resolution like to the points of the whiskers and stuff like that.
Nice. Really cool. And Diginath, thank you for the follow. And Chris TS, thank you for the resub for 11 months. Thank you, Chris. Smikes has a question about this too. If you're doing this kind of imagery, presumably there's going to be green laser. Thank you for the follow. There's going to be differences between individuals, like you were mentioning, and that might make the idea and concept of pain a little bit subjective between individuals because of that variation. So like one mouse might be making a 2 and the other mouse might be making a 0 with the same stimulus because of that variance within the trauma. How does one account for that? Or can you go and look at the genetics and be like, well, there's a 0 in this one because it has less of the receptors that you're looking at? Or is it just replicate number to wash it out, or is it something totally different?
These are cutting edge questions that we're actively trying to answer through research, like exactly what our lab does and many other labs do, because as much as we think we understand things like pain, we actually really don't. And even just facial expressions and stuff like that, it's something that we're kind of just cracking into and taking seriously after the wave of behaviorism and then the wave of like the hard neuroscience and using all of these fancy techniques like optogenetics and chemogenetics and stuff like that. We're kind of just circling back to looking at these kind of like more fine-grained things and seeing what degree of granularity do we need to get to and how much these individual differences matter. I think usually with an effect like pain, because it's such a salient survival-based stimulus, that it's something where that tends to overwhelm an individual difference. And because it comes from a reflexive survival mechanism sort of place, unless you have some sort of very rare genetic disorder and invulnerability to pain, which would kind of make you an outlier that you wouldn't include anyway, we're all going to respond to things the same way. We're all going to withdraw the hand when we hit it with a hammer. We're all going to go and probably like put your thumb in your mouth or like hold it and squeeze it, because we all have those same sort of mechanisms that don't really change from organism to organism, which is why these sorts of things are actually such great measures, because the inter-individual variability actually isn't that high. And maybe it would be if we had an even more fine-grained version of it, but for the purposes of what we're measuring here, we don't really need that. What I'm trying to determine is, are they in pain? Yes, no, binary, and a little bit of how severe is it? Is it lots pain, little pain? But pain subjectivity is the problem that all pain researchers and doctors and basically the entire world is trying to solve at all times, because you're exactly right. There's your pain, the exact same stimulus on you. You might say a 6, I might say a 10, and as for sex differences, females have notoriously a higher pain tolerance, pain threshold than males do. That it holds true across most species. and it's probably just an artifact of the fact that they bear children. If we're talking about like, you know, biologically able to bear children, you know, and not getting into gender quagmire.
When you do your research, do you have to look at the sex differences, or are you focused on one or the other?
I insist on looking at sex differences. The granting agencies in Canada and lots of the ones in the States now actually insist that if you don't use both sexes that are available, that you justify why.
Oh, cool.
Yeah, it's really cool. It's actually like a sub thing on all of our government grants now. So like our NIH style grants.
Nice. I mean, I think that's a really important component to be looking at and studying, right? Because like you were saying, like even notoriously across species, that's something that we know is a thing, and it's like if you don't ask it, well then, right? Why is that?
Yeah.
So Neuro, we have you for 8 more minutes.
Yeah. It doesn't need to be only 8 more minutes.
It is your call. I want to be. You're already kind enough to come on here. I want to respect your time. I would love to have you on for 6 hours. That's just the thing. I feel like everyone is loving the conversation. I guess, do you want to direct us to something on the slides that you like is a really like fun or exciting piece of data for us to round it out, or?
You know, I don't know that I've really sent you anything that's altogether that thrilling, if I'm being honest.
So I think chat would disagree.
Informative as possible.
Chat would disagree with you because I think the questions have been blowing up. So
yeah,
everything has been awesome.
Probably my favorite thing that I've ever done was my master's research, looking at how early life stress impacts addiction vulnerability. I've talked about it a fair bit on my stream, but very briefly, this is kind of, I think, where the elegance of up-translating or trying to up-translate stuff really kind of comes into play. Is we've tried to model early life conditions that a human being might experience. So like, you know, just mild things like being sent to school without a lunch. So what we did, instead of like, lots of stress research wants to really like kind of sledgehammer them with stress and be like, well, of course that's going to do something radical, but most people experience a little bit of stress, and how much of that you experience can actually be like really profound. It doesn't have to be you had the worst childhood ever to end up having, you know, downstream effects. So when we did this, we gave them ad libitum access to food, but only for 12 hours a day instead of 24. So that's as much like an all-you-can-eat buffet for half the day, and remembering that they sleep for half the time, right? So
what is that like? What is that like? Like you were saying, they sleep half the time. What does that look like? Like, is it they're primarily going like during the night they're awake? Like, and so when do you place the 12-hour food? Just like from a silly logistical question, how do you plan that out?
In that particular experiment, we gave them food during their active phase, so during when they would be awake.
Okay.
Just to kind of get rid of any like really overt circadian kind of effects. But you could do either. At that point, you could really do either. And the other things that we did were we exposed them to fox odor. So that's a predator. The predator's nowhere in the room. We just took literal fox pee that you would get from like Bass Pro Shops or whatever, and put it on a cotton ball at the certain, you know, thing, and put it a certain, you know, distance away, and then expose them to that for 20 minutes. So that's kind of meant to mimic like a existential threat, but no actual harm. Because there are stress models that I refuse to do because I don't even want to discuss them. It's a very stressful thing. But this is just a cognitive stressor. And even these small things went on to have really big impacts on things that we know are related to addiction vulnerability downstream. That has been published, and that's, you know, we've shown that basically it increases the number of traits that one expresses that are related to addiction vulnerability. So things like novelty preference, yes, exactly.
Is that this paper?
Novelty preference, yes. Yeah, that's the one. Is it? Yeah, it is. So basically, it doesn't change any one specific trait. So, you know, the preference for novel things, your heightened anxiety, we know is related to addiction vulnerability. Something about like hue sensitivity. So how much does it make you crave a cigarette when I hold up a lighter? You know, some people that will make them be like, ooh, you just made me think of it, now I have to have a cigarette, or whatever your addictive target thing is. There's individual variability there, and impulsivity. How much can I tell you? You have to wait. The marshmallow test that people are familiar with, those sorts of things, in any combination, are higher if you've had early life stress, and higher in females that have had early life stress than males that have had early life stress.
Wow. So there is even a sex difference on that front too.
Yes.
How much later in life do you look at? Because we talked about scalability of the life of these animals. Like, right, you said, was it like the 3 months of a mouse is not the same as the 3 months of a human, but we're kind of like how we're trying to translate it. So, like, what is later in life for these animals?
In this case, particularly, actually, you're on the exact right diagram. So we do their adversity at postnatal date. That's what PND stands for, 21, which is kind of peri-adolescence, if you will, because it's right around the time at which they start to develop into sexual maturity. And then we test them at 60 days, which is the kind of veterinary cutoff for a rat to be considered an adult rat. It's early adulthood, so this would be the equivalent of having something happen when you were kind of like 10, 11, 12, maybe 13, and then testing you when you're, 18 to 21. And yeah.
Cool. Moo was wondering, so there's studies that also use traditionally non-addictive substances to see if the addictive behavior still applies.
Absolutely there is, yeah. So we look at things like food, sucrose addiction, fat, gambling. You can't really test gaming, but there's something called the rat gambling task. It's developed actually at a Canadian university called University of British Columbia, and it's just exactly what it sounds like. There's something called the human gambling task, and they just were like, how can we see if rats can do this? And they just down translated it to a rat, and it's as close as you can get to the human version. And that speaks to the translatability of these things. Is rats will act like humans do. They'll do the things that we expect them to do when they were first developing this and piloting it out, and now that's a standard measure of gambling behavior in rats. And it's so sophisticated that whole area of research and the progeny of that lab that developed it used this technique to look at the interesting kind of intercorrelations of substance abuse and gambling, because those do tend to happen together in human beings. So you can say, if I give a rat cocaine, does it do worse on the rat gambling task? And boy, oh boy, does it. Yes.
Really?
Yeah, absolutely. Makes them more impulsive.
Do you know if it's like similar molecules that are driving those two different behaviors? Or, like, I know in flies, the big addiction behavior molecule is this neuropeptide F, which is a neuropeptide Y in humans, and that's been looked at like alcohol addiction. Is there general molecules that are involved in this, or is it like specific to each kind of behavior?
It really depends on what kind of aspect of the behavior that you're getting at, and that's where the kind of fine-toothed comb of like, while we're looking at this behavior, we need to kind of like really be understanding what about the behavior is driving it, right? Because we can be like, in a human being, you can be like, oh, it's the thrill of the thing, and like I love the rush when I hit a jackpot or whatever, right? Or I love outsmarting people when I'm doing poker. But we can't ask that of rats. But what we can do is look at, there's little lights and stuff like that they'll have in the rat gambling task that will go off, that are meant to mimic kind of a slot machine sort of thing. And we can see that they're attending to these stimuli, like orienting and approaching towards them. So we think that a lot of it does have to do with the saliency, the importantness that the animal ascribes to these environmental stimuli that are triggering, we think in this case, primarily dopamine at the front end, that's going to be basically encoding how rewarding is this experience, or how important is this experience to encode. And then downstream, the kind of valence and pleasure aspects of it starts to become more murky. As for peptides, I think that's above my pay grade, if I have to be honest. I do not know.
Yeah, it's just such a cool system to hear about. Like, I am fascinated on this rat gambling. And I love chat, really cool. Like chats, talking about, is there any card counting rats and like the little slot machines, and I think when you come back next time, I'm so sorry, I'm volunteering you to come back next time. We'll need to.
I couldn't be happier. I'd love to be on anytime.
I guess final few questions. Again, because you are at work, you need to go home. You're going to be back within a couple of hours because you're a mad scientist.
I'm really close to work. All I have to do is get up the hill, so it's not that big of a deal. But I'll answer the remaining lingering questions, and then I'll let you move on to your other stuff.
No one wants us to move on, Neuro. Everyone just wants you to stay on. So how do these cross studies relate to PTSD? So Moose says, I've read that studies say that PTSD can potentially activate the same proportion or portions of the brain that control the physical brain response.
Yeah, so in that case, I'm not a PTSD researcher, so I can only speak with like limited kind of experience here. What I would say is when we say same brain areas, it's not wrong, you know, but a lot of things activate the same brain areas, and I don't mean to harp on about dopamine, but this is actually a really perfect example of something that even like in lay culture and in science culture, we understand really, you know, poorly, I would say. Like, we think we understand it really well, and people are like, if it's dopamine, it's reward, and that means someone's going to do more of the thing. If I give you more dopamine, or more dopamine happens in your brain in certain regions, no matter the organism, that it's going to result in XYZ. But the fact of the matter is, that might be true, but most things activate dopamine. So yeah, we're saying true things, and they are all related, but kind of to what end and with what specificity. So when we say things like this phenomena or this mental health disorder activates the same brain areas as other stimuli, yeah, I think that's true. I've heard that. I think that would hold up in the literature. I don't know that that's altogether that meaningful, you know? Like it's meaningful enough to say, hey, we should look at this brain area and see more detail. And what I know about the kind of memory aspects and the stress related aspects of it is it does sensitize your stress system such that it becomes hypervigilant. So if you do a fear paradigm in rodents, where you pair, say, a loud noise with shock kind of thing. So you're, you know, making it so that stimuli, so this would be the equivalent of a car backfiring that reminds a, you know, war veteran or something like that of the sound of a gun or an explosion. You know, if we condition them that means that, but then we take out the actual negative stimulus and we just give them the sound, what should happen is that it should extinguish, right? And this is going to activate the same part of the brain, because that same part of the brain is doing the remembering and sending the remembering to the same part of the brain that was encoding that this is an important stimuli to pay attention to and to change your behavior for. What becomes interesting is how to disentangle that, how to stop that circuit from happening. So it's less about the fact that the brain areas are doing the same thing in situation A and situation B, and what brain areas are doing something different. Because those are really where we're going to get the kind of interventions and considerations that are going to get us to a solution. And yeah, we do have to understand the problem and where it's originating from, but I think that's really the early version of the question that doesn't really tell us anything that's like gonna break new ground. It's what's not happening. It's where is this part turned off? Or if I mess with this part of the brain that's not related, what happens then, right?
And then like the connectomics behind it, right? Like how everything's connected, and that's also a mystery, because I know it was like last year that we got the fly connectome. Yeah. Right, of the larval brain, but like the complexity of a mouse or a rat is like, I don't know, an absurd number of times more complex, right? And so like, how does one account for that? Like with a connectome, like you can't yet, right? So like,
yeah, you need a lot of computing power and a lot more people slicing a lot more brains.
Yeah, like the human connectome state, I think right now is just like regions of the brain that light up. We're given a stimulus, like instead of yet down to the neuron. And eventually, right, it would be but like you said, even like the computing power is a holdup for it, which I think is quite remarkable. There's that level of detail that we can go into, and where the technology is still limiting us. Like, it's not, you don't want to answer the question, you just can't yet.
Yeah, exactly.
And we'll do a final question from Fishman001, wondering, have you heard and used any of the tests with potential like recreational drugs or anything on those lines to help reduce anxiety or pain in rats or the mice studies that you're doing?
So I want to recapitulate the question. Are we asking if any of the recreational drugs have impacts on pain?
I guess, yeah, in like rats and mice, and is that something that you do in your research, or is that like independent from what you work on?
So we do look at, I'm definitely involved in some projects looking at just morphine and other opioid analgesics. I've looked at cocaine addiction before in my previous rat research and other opioid research with things like psilocybin and hallucinogens and stuff like that. We're just starting to get back into it. A lot of concern is rightfully being placed in the kind of arena of how translatable is this? Because again, the intravenous models are how we used to be giving rats cocaine. That's how most cocaine research is still done. People don't shoot up cocaine even in real life, but you can't give a rat a little straw in a mirror and tell them to insufflate it, which is the fancy word for snorting. That just isn't going to work. So, you know, a lot of this is kind of like trying to find these translational niches and where things kind of can up translate. The relatability in my kind of day-to-day is, like I said, the oral self-administration of the opioid analgesics and making that, you know, as close to how a human being would consume it as possible. How that relates to, I think they said something about anxiety.
Yeah. Yeah, so like Fishman's like saying that shroom microdosing is something that is started on vet in some locations, and so like I guess also shroom usage of it as well.
Right. So I think this is a kind of a really nice topic to end on, because our rodent models of things like anxiety, we put them in a box and we see how much they stay to the edge of the box versus the center of the box. It's called an open field test. It actually was in that paper that you're observing there. We used it. It happens to be, you were on the right thing, actually.
I didn't know if there's a model. I want to. You might give me.
Actually, there is a schematic diagram somewhere in there.
Oh, there is. Okay. Well, in that case, I want to use your paper then. I don't want to look elsewhere.
Let me see. I haven't. This paper's from 2017. It was my first author paper.
Nice. That's awesome.
It's all first, but still. Is there a schematic?
I don't see a schematic. It might have been in the supplement.
You know what? You're right. It's not. Anyways, an open field is just, it's a box, and we just see how much time they spend near the wall versus the center. Is that a valid measure of anxiety, even in a mouse?
So it's just to hope so you can see
it's just literally that. It's a box. The other thing that we use is something called the elevated plus maze, which is basically, it's exactly what it sounds like. It's plus shape. Two of the arms have walls on them, and two of them are just open platforms like a diving board. And we are like, how much time do they spend in the ones that have walls versus the ones that don't have walls? And we call that anxiety in mice and rats. And I ask you, does that sound reasonable to anybody? I don't think it does. It's the convention in our science. So to the degree that we can presumably measure some semblance of anxiety in a rodent, yeah, there has been research looking at the amelioration of that by various drugs of abuse or recreational drugs, including hallucinogens, including, amphetamines and stimulants and alcohol and all different manner of things. All of that has been done rigorously. Rigorously with what test though? I don't see any not any translational value. I see a lot of translational limitations in our gold standard tests in things like this, which is where the balance of looking at the animal and observing them and being like, do they look anxious, and having a standardized measure, you start to kind of be like, okay, at least we have a standardized measure of when they're going in the diving board arms versus the closed arms.
Well, and then these measures too, right? Presumably, like there's physical of, like the pain that you talked about, like the physical characteristics, and presumably there's something like that with the anxiety too, that you could try to measure.
Yeah, so you can measure something like corticosterone, or, CORT for short, which is, what do we call it in humans? I'm so used to calling it what it's called in mice. Cortisol. We just call it cortisol in humans. That took me a minute. So we can measure that, but that also requires taking a blood draw, which can be stressful on the animal, which can be its own confound and cause a ceiling effect. So, there are these kind of like analogous physiological biomarkers that we can presume to have. Interestingly, with the pain specifically, the dichotomy between the emotional aspect of pain and the physiological aspect of pain is actually pretty different. People's suffering levels to pain doesn't usually map on as well as you would think with injury severity or even reported pain sensation levels. And you can think about this in a way that makes sense for your own self, because you can think the distress that I have over the tiny cut that I have on my finger right now is huge because it's right on the knuckle and it gives me active daily. I'm like, damn it, I keep hitting it on things. Have I had intense abdominal pain for like a year and a half? I don't have it anymore. I got surgery for it. But did I live through that kind of like dull aching pain in my flippin' abdomen? And was it less distressing but more painful? Yes. Like, this is just simply more annoying to me and thus causes me more daily suffering than the thing that was actually quite a bit more severe. And we probably all have examples like that of just little things that get at you more than big things do.
It's like you're growing intolerance to the big thing, and it's just become your norm versus like that cut. It's like that immediate pain. Yeah.
It's remarkable to me always how people outside of the field can hit on the most cutting edge questions. We are looking at the effect of how much of our pain responses in our gold standards is due to conditioning actively in our lab right now, because we think that a lot of it is to do with conditioning. And that we need to start thinking about that in our pain measures, because we take things as gold standard and we're just like, oh, that's what that's for. And more replicate measures equals better. But each time you're doing a replicate measure, you're conditioning whatever you're doing, fly, rat, cat, dog, any organism, you are conditioning them to the conditions, the stimulus itself, and the conditions you're doing it in.
And so you're perhaps shifting the answer in one direction versus it being the actual true answer. Like, I know, I have daily pain with my...
Not even perhaps. You just are.
You just... even better. I see it, and then it gets to the question, well, then how the heck do you study the questions without replicates? It's like, you have to have replicates, but then you're getting at this question, then like you said with the mice, how do you ethically justify then not doing replicates on the animal, but having each animal be its own replicate and the numbers of it, and it's just...
The answer to that, and this is a beautiful own shoulder brush here, is the paper I was talking about that is in press this week. We just got the proofs yesterday, looked at. Then this is where immaculate record keeping is important, and data management and all of the most boring parts of science become incredibly important. Is we actually just published a retrospective study over the 20 years that the lab I work in has been operating. And it's got more than 8,000 mice worth of data for almost 100,000 replicate data samples of our gold standard measures of pain studies. And we looked over that and basically were like, hey, we have these data. And I said to my boss, we have these data because I know that you keep as good a records as I do. Why don't we dig into it? And it was a lot of flipping work, but that's how you do it is, over time you accumulate a lot of those animals, and it sounds like a very gross amount of animals if you think about doing it for the purposes of that. But this is where going back and looking at data and reconsidering things and taking new ideas from your young graduate student that doesn't have 25 years of experience in the thing. Do you see what I mean? Like, that's the beauty of science. That's where things like, talking to you gives me ideas. I'm going to go home and be like, oh, we've talked about this on stream. Maybe we should do this experiment, but I need to graduate.
And on that note, thank you so very much for coming on. I hope you had even a quarter of the amount of fun I had chatting.
Best time.
And the fact is we need you back. So give you a little break from us, but would love to have you back on. This was, we've chatted with a lot of people, but this was, again, an absolute joy to chat. Consider thinking about more questions for next time. Neurolicia, we're gonna give you the shout out. I think hopefully the cooldown is done. We can do this again. Sometimes I hate that cooldown. You know, I just want to be shouting you out all the time. No, it's there. All right, chat. If you see a heart button at the top of your chat now, please click it. Neurolicia is an amazing science communicator. I want her to have that check mark by her name. She is so kind, so thoughtful, so well explaining as well what she does. Like, she is #1 with a bullet, to quote that whatever band song that was like cool and fancy in the 90s. I don't know. Please go drop her a follow.
Fallout Boy.
There it is. There we go. Some Fallout Boy. There we go. You got the dubs on there. Again, thank you for everything you do, being a science communicator here on Twitch, joining us today. And what I know you've got some future stuff coming up. Do you want to let us know what's in store for the Neurolicia channel?
Oh boy. Well, at this point, I'm probably going to be streaming on my channel more like once a week because, again, I want to graduate, and that's a pretty big thing. And I'm also planning on moving internationally here pretty soon. So, you know, getting that under my belt and visas and stuff like that. I'm going to be American, which, you know, the land of the free and all that.
That's right.
So you know, that's probably the future of the channel. I'd love to have more of my chat and my community is amazing. We're small but mighty people, the Ratties. I love having questions from an intelligent audience, and you know, all the people that come from your stream are always just absolutely magnificent. So, you know, the future of my channel is as much open and wild and rabbit holey as my audience is wanting to be, and yeah,
there's even a redeem on your there is a redeem on your channel as well, right, where you get to like pick topics as well, so like you'll live investigate too, and it really is, y'all. I'm not just blowing smoke because Neuro's on here. Like she said, she came on I think a stream once, and she chatted, and it was like an instant friendship that started. And I am, again, proud to say that I have one of those founder badges, and
I have to get a better computer so I can actually do live, like, video, looking at videos and stuff like what you do, because my computer will just implode.
Well, no, that's how we started. When we started on a laptop, and it was so like you couldn't watch anything, but we were watching it. It was like lagging, and it was like, oh my god. But you know, you always start somewhere. And guys, her production value, beautiful. It's a great time. Please go follow. You will not be disappointed. I am so glad she was on with us today. And for anyone who missed the discussion, the VOD will be up. And again, Neuro, thank you so very much for your time. There's also a celebratory. There's a celebratory event coming as well in February, right? Sometime. We don't know yet the date.
My streamiversary is right around my birthday, so I'm going to have a birthday / streamiversary / just I haven't been on stream for a little bit. Come back, fun time, sometime in February. I'll put it on my Discord, but probably the second week of February, probably on a Friday. Fridays are kind of my jam. FAFO Friday.
Perfect. Let me grab.
Share it around and find out Fridays. For the PG crowd.
And there is your Discord invite. I just dropped it in the chat. We'll also drop.
It's up to date. I've been so bad with maintaining my stuff, so
no. We got your Twitter as well, guys. There's Neurolicia's Twitter to go follow, as well as Instagram. She always posts going live notice in the Instagram as well. Her Discord's a fun happening place. The Twitter too. Just follow her on everything, guys. Seriously, do the thing. Oh, the Discord invite is invalid. We will update that, Moo. Yeah, we will update that.
I thought it might be. Fuck. Go, sorry.
No, I don't know what you said. What are you talking about, Neuro?
I said ferret. Whoops.
Exactly. Wholesome ferret. Actually, honestly, I didn't even hear it.
I made it almost the whole stream, Balint. It's the best I could do.
Risto is grabbing a link, and we will pin it to the top of the chat. So for anyone interested in wanting to join the community directly, we'll have it pinned for the next whatever long it is. Again, ma'am, thank you so very much for your time. We'd love to have you back soon, and I will send you an image of all the stickers that you can pick from, and we'll shoot you over some pins and stickers and all the. Oh, there it is. Look at that. Risto's got it. So y'all, please join.
You're my favorite, my husband.
What is the sewers that it's called?
Oh yeah, welcome to the sewer. You are now a normal rat because of the Jordan Peterson supercut when he talks about rats. The rat goes like this. Watch it. It's the funniest thing in the world.
Awesome, guys. Please join her on all the things. You will not be disappointed. Thank you again for your time, Neuro, and we'll see you real soon.
Yes, see you. Thank you. Thanks so much, chat. Thanks, Balint. Love you guys.
Bye, Neuro. Alrighty, y'all. That was the lovely Neurolicia.